Hello, this is the second part in counter development using vunit and ghdl, and this time what we're going to do is we're going to morph the counter into an object. And by object I mean piece of code that we can actually request the counting action or delay from. Now the first thing that we do is we're going to add a record of counter record type, and in here we will go ahead and put in the counter, and then we will add a constant which is called init counter, which allows us to set initial values for all of the members inside the record. So this is of counter record type, and it has values of 0 for the counter and false for the counter is finished. Then we're gonna let's create a signal called counter object. Actually, let's name it down counter, which is counter record type, and it is initialized to init counter. Now we see here that I forgot these values here, which are not supported in the record. And that's why we have the constant, and we can see that we do not have declaration for the counter. So what we're going to do now is we're going to actually do some aliases. So we would alias counter is down counter.counter, and alias counter is finished is down counter.counter is finished. Right, so this is part one. Then what we will do is we run this again. We see that the simulation does not crash because it says that it has passed. And here we put a look at that. We can see that we have here the down counter record, and it has counter, and counter is finished. Again, since our counter is not actually initialized to any value higher than 0, we can see that it does nothing. Now, what we will do now is we will actually use the simulation counter here as a stimulus. So if simulation counter is, for example, 10, then we will put counter to 10, and if now as we run it, we can see at actually 11th clock cycle, because at 10 we set it to 10, and it runs from 10 to 0. Now the magic here happens when we actually create a procedure called create counter, which has a signal counter object that is in out type. is inout, and its type is counter record. Counter record. Then what we're gonna do is we will actually go here and take the logic and add it to the procedure here. Also, we take the aliases here and add these to the procedure. And these are counter object. So we do not have a declaration of counter. We don't mind about that yet. Then we're gonna create counter with down counter like this. And now we're gonna add another procedure called request counter, which has a signal counter object, which is in this time out, and its counter record type. And what this does is actually just counter object dot counter is set to 10. Right. Then we will actually split this here to make it a bit easier. So what we do here is we request counter down counter. Where are we still using counter? We are not using counter. So now we should be able to run it. And once we look at it, it should look exactly the same as it does. Let's just test first that we actually have something. So we change this to some other value, and we should see some change here in the gtkwave. Voila! Now as we look at the application code here, which is just this stimulus process in the test bench, we can see that we actually just have two lines of code here, which is the create counter that builds the counter from the down counter object or down counter type, and then we request some action from it, which is in this case we just request counting. Now, next thing that we're going to do is we're actually going to modify this so that we can actually have the counter value how much we are in fact requesting. Let's just call this counter value. Actually, we're going to call it count down from, and its input, and it is natural. That is range 1 to 2 to the power of 16 minus 1. So we can request a 16-bit counter value, but we cannot request for 0 count here. And here we will put the count down from. And we will request for count from 10. Again, we'll run this. That is not what we want to click. We want this. And we can see that we can actually request a down count starting from 10. And again, we will test this to, let's put 12, so we can see that it actually changes it. Yes, we saw it change, so we know that this works. Next thing that we're going to do is, because we want it to be able to check if it is ready, so we add a function called counter is ready. And this gets the counter object. And it returns boolean, which is just return counter object dot counter is finished. Now we go here and we actually have an if statement. So if counter is ready, down counter, then we will, let's say we request a count from 7. And if and we'll run the vunit script again, and here we see that now we first count down from 10 to 0, and after that, every time it is ready, we will ask for another count down from 10. And this also shows what I call the init request ready pattern, in which we create these objects. First we initialize or create some object, then we request some function from it, and then we ask or check whether or not it is ready. And these are two procedure calls for the create and request counter, and then a call to function called counter is ready. And that finishes our minimal amount of interface to our down counter object.